106.3
Radio
City High.
You listen to learn.
Grade 10 standby because up next is Mathematics Grade 10 only here at 106.3 Radio City High. You listen to learn.
Iligan City National High School campus, Radio City High, is committed to respond to the immediate education emergency. That is to widen the access to education by bringing it to where the learners are.
106.3
Radio
City High.
You listen to learn.
Good morning sa atong mga suking tigpaminaw, ilabi na sa atong mga grade 10 students. Hello kaninyo mga langga. Among pong i-greet ng amo ang mga parents, guardians, ug uban pa atong i-greet Ma'am Lorraine and Ma'am Honey, ang atong very own supervisor si Sir Aaron. Hello dira kanimo sir. Ug atong madasigon nga principal si Sir Rex Razo, ug ato ang department head si Ma'am Annabel de Guzman. Maayong hapon kanimo ma'am. Di pa na to kalimtan ang atong mga kauban sa trabaho. Hi mga ma'am and sir. So karong adlaw, stay tuned diri sa ato ang very own live on air 106.3 Radio City High. You listen to learn. Ako si Teacher Mayet, si Teacher Honey, si Teacher Lorraine. So before we will formally start, ato sang pangayoon ang panalangin sa atong Almighty God.
Our Almighty Father, we offer you this day the service to our learners, to teach them all that is good. Give us, the teachers, the divine wisdom and knowledge, because we acknowledge that we are nothing without you. Give as well, our learners, the spirit of understanding and motivation to continue education despite the challenges in life, and make them active and attentive for our lesson today. We give back all the glory and praises unto you, dear Lord, and we ask for forgiveness to all our negligence and iniquities, that we may be worthy to receive thy blessings. In Jesus' name, Amen. A group of scientists is investigating the behavior of a bouncing tennis ball. They dropped the ball from a height of 10 meters and measured its position over time. With every bounce, the ball loses some of its original height as shown in the illustration. The scientists noticed that the ball loses 20% of its height after every bounce. In other words, the maximum height of every bounce is 80% of the previous one. This allowed them to predict the height of every following bounce. So from 10 meters, we obtained 8 meters to the second bounce of the ball by multiplying 80% to 10 meters. And to predict the height of every following bounces, we multiply 80% of the previous height of the bounce of the ball.
Now we will learn more about geometric sequence and finding its end term. Given the sequence 32, 16, 8, 4, 2, and 1 is an example of a geometric sequence. So what is a geometric sequence? It is a sequence of numbers where each term after the first is found by multiplying the previous one by a fixed non-zero number called the common ratio. For example, we have 2, 4, 8, 16, 32, 64, and 128. So this sequence is a factor of 2 between each number. And each term, except the first term, is found by multiplying the previous term by 2. So in the example, we have 2 times 2 is 4, 4 times 2 is 8, and so on. So the 2 here is the fixed and non-zero number, which is called now the common ratio. The common ratio R can be determined by dividing any term in the sequence by the term that precedes it. So meaning, para daw mapangitan nato ang common ratio of every geometric sequence, we need to divide a pair of terms. So it doesn't matter which pair as long as they are right next to each other. So balik ta sa atong example sa atong geometric sequence, which is 32, 16, 8, 4, 2, and 1. So the ratio now is equal to 1/2. Why 1/2? 16 divided by 32 is equal to 1/2. So makita nato no nga ang 32 ug ang 16 nagtapad gid siya.
To calculate for the any term within a sequence, or to find the nth term of a geometric sequence, we will use the formula a sub n is equal to a sub 1 multiplied by the ratio to the power of n minus 1, where n is the position of the term in the sequence, or mao na siya ang mga number of terms nga gipangita. And a sub 1 is the first term, and r is the common ratio. Let's go for our example. Calculate the 10th term of this geometric sequence. 10, 30, 90, 270, 810, and 2,430. Para dali nato makuha ang ato ang nth term, dapat kabaluta first mo identify sa mga unknown. The first one is n. So mao ni ang again position of the term in the sequence. So ikapila nga term ang gipangita. So in this given, we have n is equal to 10. Now the first term now is also 10, and to get the ratio, kinahanglan magkuha ta og duha ka numbers right next to each other, and then we will divide. So we will have 90, for example. So 90 divided by 30, so we have 3. Or 30 divided by 10, we also have 3. So that's r is equal to 3, the common ratio. Using now the formula a sub n is equal to a sub 1 multiplied by the ratio to the power of n minus 1, substitute all the given. So a sub 10 is equal to 10, which is the first term, times 3, which is the ratio, to the power of 10 minus 1. So a sub 10 now is equal to 10 times 3 to the power of 9, which is 10 minus 1, so we have 9. Now 3 to the power of 9 is equivalent to 19,683. Multiplied now by 10, so we have the result that the 10th term of the given sequence is 196,830. Another example of geometric sequence is we have 4, 2, 1, 0.5, 0.25, and so on. So again, first identify the unknown, the position of the term in the sequence, which is n. So n is equal to 6. And then we have the first term, which is 4. And then get the common ratio. So given the sequence, so if we choose 2, then 2 divided by 4, that is 1/2. Or automatically, if we will choose 1 divided by 2, so again, r is equal to 1/2. That is the common ratio. Now, using now the given formula, we have a sub n is equal to a sub 1 times r to the power of n minus 1. So, atuan na pong isubstitute ang mga given. A sub 6 is equal to 4, which is the first term, multiplied by 1/2, which is the ratio to the power of 6 minus 1. Where the exponent 6 minus 1, we have 5. So 4 times 1/2 to the power of 5. So 1/2 to the power of 5 is equivalent to 0.03125. Multiplied by 4, so we have the result of 0.125. So the sixth term now is 0.125. Now, it's your turn. So, tanawin nato kung naabay na sabtan sa ato ang discussion. I will just give a matter of 15 seconds para mansira ninyo ang given problem. What is the 11th term of the geometric sequence 3, 6, 12, 24, and so on? So kindly check your answer. We have the 11th term is equal to 3,072. Now, if wala ninyo nakuha ang correct answer, so go back mo sa ato ang given problem. Maybe naalay gamay nga sayo para masakto na gid siya. So again, another one. What is the ninth term of the geometric sequence 81, 27, 9, and 3? Okay, so I think you got the correct answer, which is the ninth term is equal to 1 over 81. Inserting a certain number of terms between two given terms of a geometric sequence is an interesting activity in studying geometric sequence. So, Ma'am Lorraine will elaborate it. Thank you.
Okay, thank you kaayo Mamayet. So, ang akong topic is solving geometric means. So before ta mag-solve sa geometric means, ato sa tukion unsa baning geometric means. Geometric means are the terms between any two given terms of a geometric sequence. So kung baga pa, when you say geometric means, mga term or terms nga in between two terms in a geometric sequence. So ang pangutana karon, unsaon man pagkuha sa geometric means sa usa ka geometric sequence? Pwede na magamit ang formula sa geometric sequence. Mauni ang a sub n equals a sub 1 times r to the power of n minus 1. Where a sub n is the last term, a sub 1 is the first term, r is the common ratio, and n is the number of terms. So karon, let's have an example. Example number 1. Find the geometric mean between 10 and 40. So kani sa problem, isa lang ka geometric mean ang naa sa tunga-tunga sa 10 o 40. So, kung atong isulat, we have 10, then space, the geometric mean nga atong isolve, so blank, and then 40. So, para masolve tani, natay duha ka solusyon, natay duha ka pamaagi. Bisag asa ni nga pamaagi, you will get the same result. Una, ang unang solution is ani. Atong i-multiply ang first term sa last term. Atong i-multiply ang 10 sa 40. So that becomes 10 times 40 is equals to 400. After Anna, you will then get the square root of 400. And what is the answer to the square root of 400? That is 20. So therefore, the geometric mean is 20 and our geometric sequence now becomes 10, 20, 40. So, complete na. Okay. The other solution, using the formula of the geometric sequence, which is a sub n equals a sub 1 times r to the power of n minus 1. Now, unsa may given ani atong problem? Ang atong last term, which is a sub n equals 40. Ang atong first term is 10. And ang atong number of terms or atong n. So, kung imong lantawon natay 1, 2, 3. That is 10, blank, and 40. So there are 3 terms. So, ato din na siyang i-substitute sa ato ang formula. So our a sub n equals a sub 1 times r to the power of n minus 1. So you have 40 equals 10 times r to the power of 3 minus 1. Then to simplify, we have 40 equals 10 r to the power of 2 because that is 3 minus 1 becomes 2. And then we will divide both sides by 10. So we will have 40 divide 10 equals 10 divide 10, then r squared. So you have, eliminate na ang 10. So we have 40 divide 10, that is 4, equals r squared. And then get the square root of both sides. And therefore, the result is 2. That is our r. That is not yet the answer, ha? Dili pa na mao ang answer. Now, unsa may buhaton aning r nga 2? Ang atong ibuhaton ani, ato ning i-multiply ang r equals 2 sa first term sa atong sequence. So that is 2 times 10 equals 20. And that is the next term after 10. So therefore, our geometric mean is 20. O, diba? You will get the same result. Okay, let's have another example. Example number 2. Find the three geometric means between 32 and 1 over 8. 32 and 1 over 8. Pila ka buok ang atong i-insert nga geometric means? There are 3. So ato isulat. 32, comma, 1, space, space, and space. The next is 1 over 8. So there are 3 geometric means that we need to look for. So let us start with the given. What is our last term? That is our a sub n. That is 1 over 8. Then, a sub 1 is 32, or our first term. Then our n is 5. So, with the use of the formula, we have a sub n equals a sub 1 times r to the power of n minus 1. That becomes 1 over 8 equals 32 r to the power of 5 minus 1. Then, simplifying it, we have 1 over 8 equals 32 r to the power of 4. Again, divide both sides by 32 to get the r. So, 32, divide both sides by 32. So, we will have 1 over 8 divide 32 equals 32r to the power of 4 over 32. Then, to simplify, you multiply the denominator 8 by the 32. So, that becomes 1 all over 256, which is equals to r to the power of 4. And then, get the fourth root of both sides so that we can get the value of r. So your r now becomes 1 all over 4. It's because when you multiply 4 to itself 4 times, you will have the result of 256. That is why the simplest form of the fourth root of 1 over 256 is equals to 1/4. And that is not yet the answer. Okay? Remember, r is a common ratio. Okay, next. Unsay buhaton anang r equals 1/4? Mo na atong i-multiply dadto sa first term sa atong sequence. Sige, 32 times 1/4 equals 8. And that is the next term. The next, 8 times 1/4 equals 2. That is the third term. Next, 2 times 1/4 equals 1/2. And that is the fourth term. And let's check if the next term would be 1 over 8. So 1/2 times 1/4 is equals to 1 all over 8. So, therefore, our three geometric means between 32 and 1 over 8 are 8, 2, and 1/2. So, is it clear to you now on how to get the geometric means? So, dali ra siya. Simple lang siya buhaton as long as you will follow the formula of the geometric sequence. Okay, and then the last example before we will proceed to our next topic. So we have the third example. If the third term of the geometric sequence is 9 and the sixth term is negative 243, write the first 6 terms of the sequence. So unsay given? Pila ka. O sige, ato siyang sugdan sa ato ang last na sentence. How? Write the first 6 terms of the sequence. So there are 6 terms. Nga gipangita. And what are the other given? Sixth term is the last term, which is negative 243. Then the third term is 9. So therefore, ang third term is 9. And the sixth term is negative 243. So, between 9 and negative 243 na ay duha nga blank, and before sa 9, yan apoy duha ka blank. So, how are we going to find it? So, ani ang atong unahon? We will assume 9 is our first term. So, a sub 1 equals 9. Dayon, ang ato ang last term is negative 243. So, how many number of terms do we have now starting from 9? So there are only 4. So our n is equals to 4. So using the formula, we have a sub n equals a sub 1 times r to the power of n minus 1. So ang atong last term is negative 243 is equals to 9 times r to the power of 4 minus 1. And then divide both sides by 9. So we have negative 243 divide 9. Then equals 9r cubed divided by 9. So you will have negative 27 is equals to r cubed. And let's get the cube root of both sides. We will have r is equals to negative 3. So again, since r is not yet the answer, negative 3 nga r, we will multiply it to the first term. Unsa man nga term ang first dire nga atong gi-assume, that is 9. So we have 9 times negative 3 equals negative 27. So meaning that's the next term. Next, negative 27 times negative 3, that is 81. That is the next term. And let us check if the next of 81 is negative 243. So 81 times negative 3 is equals to negative 243. So that is correct. Now, how to get the numbers or terms below 9 or before 9? So in order to get the two terms before 9, we will simply divide 9 by negative 3, which is our r. So 9 divide negative 3 equals negative 3. So that is the term before 9. And then next, negative 3 divide negative 3, that is equals to 1. So therefore, the first 6 terms of the sequence are 1, negative 3, 9, negative 27, 81, and negative 243. So that is the simple way on how to find the geometric means of a geometric sequence. So I hope you have learned something from this. So I think the next topic will be discussed by Ma'am Honey. So Ma'am Honey, take it away.
Thank you, Ma'am Lorraine. And thank you also for defining geometric sequence, Ma'am Mayet. This time, we will discuss geometric series. But first, we will deal with the finite geometric series. In the previous lessons on arithmetic series, we say series or we define series as the sum of the terms in that sequence. So if we are going to define geometric series or finite geometric series, it is just the sum of terms in a geometric sequence. So still, we will be dealing with geometric sequence, but this time, we are going to find the sum of terms of its terms. In dealing with geometric series, especially with finite geometric series, there are conditions that has to be satisfied, and we are to check this in a given geometric sequences. First, if r is not equal to 1, we know that r is the common ratio. If r is not equal to 1, then our formula in finding the sum of terms in that geometric sequence is defined as S sub n equals a sub 1 times the quantity 1 minus r raised to the power of n all over 1 minus r. So we are to put into our mind that this only applies if r is not equal to 1. What if r is equal to 1? Then it is just easy to take the sum of terms as the product of the first term multiplied how many terms are there. So a sub 1 times n. But what if our r or our common ratio is negative 1 and our n is even? Automatically, the sum of terms in that finite geometric series is 0. And for our last condition, if r or our common ratio is negative 1 and then our n is odd, then we can automatically say that the sum of terms in a geometric sequence given finite is just the first term. So do not forget that a sub 1 is our first term, our n is the number of terms, our r is always the common ratio, and our s sub n is the notation for the sum of geometric sequence. Let's have this concrete example. So again, bear in mind that there are 4 conditions, different conditions. First, if r is equal to 1, or r is not equal to 1, and if r is equal to negative 1 and n is odd, or if r is equal to negative 1 and n is even. So there are corresponding formulas to take up to determine the sum of the terms in a finite geometric series. First example, find the sum of the first 25 terms of 11, 11, 11, 11, and so on. What do you notice to this geometric sequence? Okay, so if you are to take the solution, first determine first your common ratio. Since our geometric sequence is our sequence is 11, 11, 11, 11, so on. It is just easy to take that r is just equal to 1. Okay, knowing that our r here is equal to 1, then we go back to our conditions, the list of conditions. Where does this belongs? So we have in the formula of a sub 1 times n. Again, n is the number of terms and a sub 1 is the first term. So we can say that our s sub 25, or the sum of the first 25 terms of our geometric sequence, is a sub 1 times n, which is just 11 times 25, and that is 275. Okay, therefore, we can say that the sum of the first 25 terms of the geometric sequence 11, 11, 11, 11, and so on is equal to 275. Okay, shall we proceed with another example? Find the sum of the first 47 terms of 17, negative 17, another 17, negative 17, and so on. Okay, your n is 47. First term here is negative 17, and then your first term is 17, second term is negative 17, followed by 17, and then negative 7, so on. So what have you noticed in our geometric sequence? We have our common ratio as negative 1. So negative 1, we must identify whether our n is odd or even? So what do you think? 47 is? Yes, 47 is an odd number. So since r is negative 1 and our n is an odd number, then we can say that we must use our formula for s sub n as a sub 1, or just the first term. So in this case, the sum of the first 47 terms of this geometric sequence is 17. Okay, it just makes sense because if you are going to add the first two terms, it equals to 0. And then add the next second term of the next two terms, again 0. But if it is odd, then automatically the first term is the sum of the first odd number. Okay, so let's take up another example. This time it is an even number. Okay, so we have the geometric sequence negative 14, 14, negative 14, and 14. And then we are to take the sum of the first 36 terms. Again, our ratio is computed as the second term divided by the first term, or the ratio of two consecutive terms in the geometric sequence. So we have negative 1 in here, and our n is clearly an even number because of 36. 36 is an even number. Okay, so automatically our s sub n, or the sum of the first even number of terms, is 0. So again, it just makes sense because if we pair up these terms in the given geometric sequences, since it is odd, then their sum is 0. So our s sub 36 is 0. Again, the sum of the first 36 terms of the sequence is negative 14, sequence negative 14, 14, negative 14, 14 is equal to 0. Okay, what if we have this sequence? Find the sum of the first 7 terms of 16, 32, 64, and so on. And we are dealing with finite geometric sequence. 16, 32, 64. What is our common ratio? We have 2. And where does this common ratio r equals 2 belongs? In the list of our conditions defined earlier. Okay, so we have r is not equal to 1. So this time we can use our formula s sub n equals the ratio of a sub 1 times the quantity 1 minus r raised to the power of n and 1 minus r. So we will just substitute our given values a sub 1, which is our first term, that is 16, and our r, which is our common ratio, that is equivalent to 2, and our n, which is from the problem, we can say that it is 7. So this time, we must compute by properly substituting our given values to our formula. Okay, so again, substitute properly. So here we have s sub 7 equals 16 times the quantity 1 minus 2 raised to the power of 7 all over 1 minus 2. Okay. So in here we have to take up first the exponents, which is 2 raised to the power of 7. And we have 16 times the quantity 1 minus 128 over negative 1 that is coming from 1 minus 2. So after that step, we subtract 1 and 128, getting negative 127. Multiply that to 16 and divide to negative 1, which will give us the sum of the first 7 terms, 2032. A positive 2032. Okay, any questions? You may write your questions and chat personally your teachers in Mathematics 10 if you have some clarifications or misunderstandings on the given formulas or the given conditions for the geometric series. Okay, another example we have here the sequence 27, 9, 3. As you can see, this is a decreasing sequence. So we are to find the sum of the first 6 terms. We are to solve first our common ratio, that is 9 divided by 27 or 3 divided by 9, which is 1/3. Okay, we know that r is not equal to 1. 1/3. And then, we can use this formula. Again, in using this formula, we are to determine these values, the a sub 1, the r, and the n. And that is 27, the first term, 6, the number of terms, 1/3 is the common ratio, and we are to find the s sub n, or the sum of the first n terms. So again, to minimize our errors, at first we have to substitute without erasity. Okay, so we have 27 times the quantity 1 minus 1/3 raised to the power of 6 all over 1 minus 1/3. Again, given this equation, let us first compute this power 1/3 raised to the power of 6. We have 1 over 729. And subtract 1 and 1 over 729. That gives us 728 over 729. And for our denominator, 1 minus 1/3 is just 2/3. So simplifying our equation. Okay, have you noticed that in our denominator, 729 becomes 27 squared. And we are looking for the ways to simplify our numerator here. So in this case, 27 divided by 27 is 1. So you're left with only one multiple of 27. So 728 over 27. And on our denominator, 2/3 remains. So dividing fractions, that is just multiplying 728 over 27 and 3/2. So we get 2184 over 54 as our sum of the first 6 terms. Can this still be expressed in lowest terms? Yes, and that is 364 over 9. So the sum of the first 6 terms of this given geometric sequence is 27, 9, 3, and so on is 364 over 9. If you wanted to express that in a decimal form, we have 40.44. But that's just all about the sum of finite geometric sequence. How about the sum of infinite geometric sequence? Is it possible to take the sum of an infinite geometric sequence? We will take up that after this one. So if geometric series for finite gives us the definition of as the sum of terms in geometric sequence, in here it is still the sum of the terms, but we are now dealing with infinite geometric sequence. And there are steps in taking up the sum of the terms in an infinite geometric sequence. The first one, we are to determine the value of our common ratio. Determine if it is greater than or equal to 1, or if it is less than or equal to -1. Automatically, if that's the case, then it is impossible to get the sum. Again, just bear in mind that if our common ratio is greater than or equal to 1, or it also satisfies that it is less than or equal to -1, then there has no ways to get the sum of the geometric series of an infinite geometric series. But if our common ratio is in between -1 and 1, then it is possible to get the sum. If it is possible to get the sum, then we can use this formula. S sub n equals a sub 1 over 1 minus r. Wherein, again, our n is the number of terms, our a sub 1 is the first term, and our r is the common ratio. So we are to take or to solve for the sum of the geometric sequence. Let's have example. In this sequence 8, 24, 72, 216, we are to find its sum. So again, the first step is to solve for the common ratio. And in here, we have a common ratio of 3. And we know that 3 is greater than or equal to 1. Automatically, it is impossible to get the sum. So are we to continue these steps in solving the sum of the infinite geometric sequence? No, because again, it is impossible to get the sum. But what if you're given 3/4, 3/8, 3/16, 3/32, and so on? First, again, make sure that our r is in between -1 and 1 to solve for its sum. But if it's not, then it's impossible. So in here, solving our common ratio, we obtain 1/2. So since 1/2 is in between -1 and 1, then it is possible to get the sum. So if it is possible to get the sum, our formula again for our sum of infinite geometric sequence is a sub 1 over 1 minus r. Again, a sub 1 is our first term and our r is our common ratio. So it is not hard for us to look for these values. So just substitute properly. So our first term is 3/4. We write 3/4 in the numerator, and in the denominator we have 1 minus 1/2. Solving first our denominator, 1 minus 1/2, we have 1/2. And then 3/4 divided by 1/2 is just multiplying 3/4 and 2. That is 6 over 4. Simplifying, we have 3 halves. So our S sub n, or the sum of the given infinite geometric sequence, is 3 halves. Okay, shall we have another example? 5, negative 5, 5, negative 5, and so on. Notice that our common ratio here is negative 1. And since negative 1 doesn't meet our goal that it has to be in between negative 1 and 1 but not including negative 1 and 1, so it is impossible for us to get the sum. Okay. Next example, we have negative 1 over 9, 1 over 27, negative 1 over 81, 1 over 243, and so on. First, let us take up the common ratio, dividing our 1 over 27 and negative 1 over 9. We get negative 1/3. And negative 1/3 is in between negative 1 to 1. So it is possible, indeed possible, to get the sum. So there's typographical error. Our R must be negative 1/3. Okay, so our first term is negative 1 over 9. So you write negative 1 over 9 on our denominator and on our numerator rather, and on our denominator we subtract 1 and our common ratio negative 1/3. Okay, so the difference between 1 and negative 1/3 is 4/3. So our dividing fractions, we have negative 1 over 9 times 3/4, and that is just negative 3 over 36. Simplifying, that is negative 1 over 12. So our S sub n, here we don't know our n because it is infinite. We are dealing with infinite again. So S sub n is negative 1 over 12. Okay, I think that concludes our discussion. I hope you learned something, and if you have some clarifications or questions regarding our lessons, since geometric sequence, geometric means up until the geometric series infinite and infinite, you may PM your teachers, chat them through Messenger, or text them if you have their personal contact numbers for your questions. Thank you for listening. I hope you enjoyed this radio-based instruction in mathematics